Good morning or good afternoon, everyone. Thank you for joining us today. This is the Hashicorp Virtual Roadshow. And for the next 30 or so minutes, I'm going to take you on a journey to hybrid cloud with the Cisco ACI, that's the application-centric infrastructure, and Hashicorp Terraform. My name is Jim Mathers. I'm a product manager in Cisco's cloud networking group, focusing on ACI and the ACI ecosystem, including infrastructure as code partners like Hashicorp. For those of you that were able to read the abstract, you will know that there are two fundamental disruptions underway in the enterprise IT space. The first is the transition from a traditional monolithic and box-by-box configuration paradigm to more of a DevOps paradigm, where IT engineers that were traditionally configuring items on a box-by-box basis are now being asked to write scripting code, usually in Python, or most commonly these days in Python, and to adopt infrastructure as code platforms like Terraform in order to keep up with application development and the speed to market that is required in modern IT. The second big disruption that is occurring is that more and more enterprises are deciding to extend their application landscapes from the on-premises or the on-prem data center into a public cloud provider. Public cloud being AWS, Azure, or Google Cloud. This transition to this hybrid cloud model presents challenges. From a connectivity and a policy perspective, but also from an automation perspective. And we are going to explore those challenges over the next 30 to 35 minutes here. So as I was building this story, it dawned on me that this is really a story about planning. And so I'm going to tell you a story about planning, and that story is about guy number one and guy number two, who you see in the slide here. Guy number one and guy number two are in a race, but the race is not typical. It's not typical for three reasons. The first is that the race takes place in a foreign land. Neither guy number one or guy number two has ever been to the place where the race is taking place. The second thing is this is not a short race. This race is a 2-day journey by cart. So it's not quick, and it will require planning. Finally, guy number one and guy number two are given identical equipment to get from where they are now to where they're going. So guy number one and guy number two come up at the starting line, and the starter says, ready, steady, go. Well, guy number one puts the pedal to the metal and zooms off into the horizon. 15 seconds after the beginning of the race, all that you can see from guy number one is a cloud of dust on the horizon. Guy number two is just sitting there. He's sort of looking around. He's got his hands on the wheel, and he looks up at the starter and he says, wait a second, where are we going again? And the starter tells him where he's going, and he writes it down on a piece of paper. He looks around some more, he looks behind him, and then he says, well, hold on for a second, where are we right now? Again, the starter tells him this is where you are. So guy number two looks in the back of his cart, he pulls out a laptop, he goes to Google Maps, and he gets a turn-by-turn navigation map from where he is now to where he's going. But guy number two doesn't stop there. He notices that the route that Google Maps has taken him on will be a coastal route. So he goes to weather.com using that same laptop and finds that there is a terrible monsoon that is supposed to hit in the next 2 days. So instead of taking the coastal route, he tunes Google Maps to take him around the monsoon so that he can avoid the weather. So if I were to ask the group, if guy number one and guy number two ran this exact same race 100 times in 100 different foreign lands, who do you think would win the race the most? And clearly what I'm getting at here is that guy number two would win the race the most because he did more planning. Did he do so much planning that it disrupted him or that he would lose the race? No, absolutely not. He did the appropriate amount of planning for the task at hand. And so what I want to do over the next 30 minutes is overlay this race between guy number one and guy number two into a hybrid network deployment with automation. So with that said, the big three things we're going to talk about from a hybrid cloud networking perspective are considerations for design, deployment, and management. Now, I do want to take a quick minute here to talk about some very important things that we are not going to talk about in this talk. So this talk is going to focus on hybrid cloud networking and automation. With that said, there is a lot more to invading the public cloud and automation than just the networking, the NetOps persona. Namely these two things here. We are not going to talk about these two things, although they are very important. Highly recommend, as you consider your cloud journeys, monolithic applications may not perform or provide you the experience that you were hoping for in a public cloud. And also, cloud native application architectures are something that these are very important things that in this presentation we are not going to touch on, but that doesn't mean they're not important. So what types of questions should we ask when we are planning for a hybrid cloud network design? They really revolve around three things, and that is going to be connectivity, security, and culture. And so having done this myself, I can speak a little bit to planning for these things. So when we choose a public cloud provider, how will the on-prem data center connect to the public cloud? Will we use the public internet with IPsec? Will we use a private line? Will we use some other type of connectivity? What are the performance considerations? How are the users going to interact with this application? Will the front end and the data sit in the same place, or will they be separated by the internet and the public cloud? These are things to consider. These are guy number 2 type questions that we want to ask when we're planning for this hybrid cloud model. The second point here is probably the most important. And what are the InfoSec considerations? What does the global information security team think about the modeling we are doing for network hybrid cloud? How many network security enforcement points will be in the path? And are these enforcement points centrally managed or discrete? What I mean by an enforcement point is typically a firewall or an antivirus scanner. When we go into the public cloud from a hybrid cloud networking perspective, how complex of a path are we building? And are the IT infrastructure components in that path configured manually or using automation? And is there an approval workflow? Because all these things will be made more complex in the public cloud. And then finally what is the current cloud culture? Do we have a public cloud installation now that might be isolated? Do we have a cloud ops team that is responsible for configuring these public cloud sites? These are all questions we should absolutely consider before we make a decision about moving into a hybrid cloud. So we just talked about design, things to think about before making purchasing decisions. Now let's talk about day-to-day deployment of hybrid cloud networks. What are the current steps that NetOps might take to onboard a new application on-prem? How will those change when an application might be stretched between an on-premises environment and a public cloud environment? When requests come in for things like new networks and IP addresses and gateways and security rules, how are they going to be deployed? How are they deployed today? Is it manual? Are the devices that we are configuring API-based? Are they CLI-based? Are they GUI-based? Do they have centralized control, or are they discrete? And finally, does the IT organization already have a centrally managed automation platform? Perhaps in some IT organizations, there is a team that will build an automation platform and then provide the services of that automation platform to other teams like NetOps. So these are absolutely things to talk about when you're talking about day-to-day deployment of hybrid cloud network constructs. The last one I'm going to go very quickly through here, but one thing that can occur from a network operations perspective as we extend into hybrid cloud is the loss of visibility and the loss of monitoring capability. So these are things we want to ask up front. Also, we want to make sure we have appropriate insight into workloads so that we can do capacity planning, both in the on-premises environment and in the public cloud. And finally, I think I read a recent article on LinkedIn that something like 40% of a network engineer's time is spent troubleshooting. So we clearly want to reduce that, and we want to make sure that we have this visibility and monitoring capability in addition to other tools that we might get in a public cloud environment so that we can continue to be effective in our troubleshooting efforts. So how does Cisco see this? This slide right here is sort of a summary of the points that I've brought up in my question asking model there. When we extend to hybrid clouds, the biggest core customer challenges are connectivity, security, and visibility. Now, as we progress through the presentation, we're also going to start to talk a lot about automation, Terraform specifically, and Hashicorp. And we're going to understand that NetOps needs to work with the developers to come up with a declarative way to build networks that will match with the application requirements, and for the applications to signal things to the network components in order to dynamically and automatically update configurations. So let's take a quick minute to introduce Cisco ACI. Now, what is ACI and what makes it unique? So ACI stands for Application-Centric Infrastructure. It really is the first intent-based networking product that came to the market 7 or 8 years ago now. So when it comes to understanding what ACI is, it helps to understand what it is not. So on the right-hand side of this slide here, we have a traditional network fabric. These days, there has been a general consolidation of network hierarchy designs to spine, leaf, and then VM, container, bare metal workload. So in a traditional network fabric, every device has its own management and control plane. And that means that each device has to be configured separately, one by one. It also means that the scaling envelope, the TCAM space, the MAC address scale, the IP routing scale, also has to be managed on a box-by-box basis. Now, in the picture there, that could work quite well for maybe 6 leaf switches. But what if you had 60? What if you had 600? So this is where the vision for ACI was built. It was built on the notion that we are going to provide a single network controller called the APIC that will be responsible for configuring the entire fabric, whether it is 10, 100, or 1,000 switches. And this APIC is quite cloud-like in that it provides a single northbound API that automation platforms and general scripting languages can use to configure the entire fabric. So the APIC provides a single point of management, a unified control plane, and manages the aggregate fabric-wide scaling envelope, which can provide enormous advantages over a traditional fabric where we are managing on a box-by-box basis. So as it relates to hybrid cloud, how does Cisco ACI compare to a traditional data center fabric? As you can see on the left here, the single point of config is provided by ACI. The single source of configuration truth is provided by ACI. And instead of a box-by-box automation target, we have a single automation target. In the APIC. Now, everything I just talked about was for the first and second generations of ACI, which were all on-premise. You may be asking yourself now, why is Cisco ACI appealing for hybrid cloud networking? Well, the first big one is that about 3 years ago, we introduced Cloud ACI and the Cloud APIC, which is an inbuilt native extension to ACI to all 3 public clouds. And I know there are more than 3, but when I say all 3, I mean all 3 big ones, AWS, Azure, and GCP. Another reason ACI is appealing for hybrid cloud is because it's an API-driven deployment model. I talked about that in a previous slide, and that makes ACI and Cloud ACI very cloud-like in how we are consuming these services and configuring. We also have a single point of administration. For a routing domain or a policy domain that needs to stretch between an on-premises site and a cloud site. Having a single point of administration and a single policy model greatly helps in the ramp up, the time it takes to get an engineering group, an infrastructure engineering group from where they are now to where they are capable of deploying these constructs. It lowers that time a great bit. We talked about cloud-like deployments. Not only do we have this API-driven configuration plane, you'll notice in the slide coming up that the policy model in ACI very closely maps to the policy model in public cloud. So it's not a very long jump from how do my network constructs look in ACI to how they look in the public cloud. The last two here are really the big ones. I'm going to spend some time on them. For those of you who have deployed into public clouds and you've stretched your networks on-premise into those public clouds, you know that there is no unification of the policy. What is called a route or a VRF or a VM on-prem is called something very different in the public cloud. So there is a great market need to unify these policy models between on-premises and the public cloud, again, to decrease, the time it takes to deploy applications and to ramp up the skill set of an engineer that is just being introduced to cloud constructs. The second here is the automation of the data center interconnect using what I call a prescriptive DCI design and provisioning. And again, if you've ever tried to connect an AWS or an Azure or a GCP into your on-premise data center manually, you'll know that can be quite a challenging endeavor. So what is this descriptive DCI design? So for the rest of the presentation here, I'm going to use AWS because it is the most common deployment for public cloud, and it's the most common one that we see at Cisco with Cloud ACI. So here you have a relatively simple picture of an on-premises ACI network. And in the infrastructure VPC in an Amazon region, we have a cloud APIC deployment. Now, in order to onboard both of these sites and to be able to stretch connectivity and policy, we're introducing a Cisco product called the Nexus Dashboard Orchestrator, which is part of the ACI software suite and allows us to stretch or extend a single ACI installation to multiple installations, either multiple on-premise or multiple public cloud. Now, the nice thing about NDO is it can automate the provisioning of the DCI. And I say that because, and this slide will go into perhaps more detail than I needed to go into, but having done this many times, this is not a simple exercise. And so the automation of this DCI, again, allows us to bring these things to market and bring these applications to your customers faster. So I'm going to briefly go through this right here. The main components of this DCI, in this case, we're using the public internet, are a secure mechanism to transfer data. We call that the underlay with an IPsec tunnel. A BGP EVPN session, which will extend the VXLAN data plane, which is the de facto data plane now in most data center networks, from the on-premises site into the cloud site using the Cisco Cloud Services Router. Again, this is quite a gargantuan feat to extend on-premises data centers and IP space and things like that into public cloud. So the idea here with Cloud ACI is to make this simpler. On the right-hand side here, we are bringing in our user VPCs, routing from the hub router here in the Amazon site. And what this allows us to do is to get these packets across this network as if they were local. And so NDO, Nexus Dashboard Orchestrator, combined with Cloud APIC and ACI, can ease the burden of administration of the data center interconnect, which is a big challenge in public cloud. So this is a slide we've seen before. I said there were two big things that I'm going to focus on from this slide. The second here is this unified policy model. Now, what do I mean by unified policy model, and what is the unification of the policy model? So again, for those of you that are already in AWS or Azure or Google, you already know all of these terms. But what you see here is a mapping of what, from a networking perspective, of what all the cloud network natives, how they map back to ACI natives. And one of the big benefits of Cloud ACI is that we abstract all the complexity of the different natives across the different public cloud providers into a single policy model. Now, I've only used the top level network native construct here just to show an example of the abstraction. But if, again, using Amazon as a model here, this is how the Cloud ACI policy model maps exactly to an AWS policy model. And you can imagine without Cloud ACI or without ACI at all, trying to map the network natives of whatever solution you've chosen on-prem into AWS can be very, very challenging. So again, as we decided how to build Cloud ACI, one of our big tenets was we want to abstract the public cloud policy model to ramp the learning curve and to bring applications to market faster. So what does that allow us to do with this unified policy story? We've already seen how a Cloud ACI can automate the provisioning of the interconnect with NDO, but now we're actually able to deploy security policy across public cloud and on-premises cloud using a single policy model and a single configuration. So right here, what we have are what we call an endpoint group, an ACI, that is mapped via the Cloud ACI to a security group so that we can have VMs that are part of an application on-prem and AWS instances that are part of the same application but stretched into the cloud in a single security group so that they can talk to each other. So this is a very powerful component of Cloud ACI and the story that we have to stretch from on-premises into the public cloud. So what are the use cases? So again, I don't want to spend too much time on this slide because these use cases are the common ones, but there are many other ones that our customers have come to us about. The big one I'll touch on is resource elasticity. As we saw in the previous slide, stretching a workload from on-premise into the public cloud where the price point might be different or the performance might be different is made possible via the unification of the policy model. Another very big place that people are getting started with Cloud ACI is for business continuity and disaster recovery. Footprints, if you will, or pictures of applications that exist on-prem exist also in the public cloud with a unified routing model or a stretched routing domain and a stretched policy domain. All right, so with that, we talked about two disruptions. The first disruption was this exploration into hybrid cloud from on-prem. The second was the advent of DevOps and the fact that in order to keep up with the rapid pace of application development, network operators are now being asked to do more with less. And one way to do that is using infrastructure as code. Now, I always start these talks, or I have been recently, with this picture right here. I want to go back to my story about guy number one and guy number two and overlay what you see here in this picture. So if you'll recall, guy number one, even though he was in a foreign land and he was a 2-day journey by cart, decided to do no planning and put the pedal to the metal and ultimately lost the race. So what you see here on the left of this slide are what I call the wrong way to do automation. Now, this typically occurs when a team of engineers decides that in a vacuum, I see this automation task, I want to write code to make it easier, I want to publish it to my teammates, and then we're going to free up all this extra time to do other things, more strategic things. What happens in reality, though, is what is here on the lower chart. And that is we write the code, then we realize maybe we made a mistake or it doesn't work. We have no support for it. So we rethink, we debug. And sooner or later, the support of this code becomes an ongoing development task. And we've actually made the problem of automation worse. So the way I like to think about this is, you know, guy number one starts fast, but did guy number one plan like guy number two? And the answer here is no. So what would guy number two's approach be? So guy number two's approach would be to ask some questions about what we want our automation platform to look like and what steps we want to take to make sure we are going to be efficient, to collaborate with a secure and governed and compliant automation platform. That usually means the automation platform itself should be centralized. It should be supported. It should include things like role-based access control. It should include hooks to Git or another version control system. And it probably should include a CI/CD pipeline or something to make sure that the changes our network operators are making are not going to cause any problems and are going to be deployed without problem. So another question that should be asked is, should we build our own automation platform? I mentioned earlier, depending on the size of the enterprise, there may be a centralized team that has a Terraform enterprise product or another automation platform that is supported and does have the items and the bullets on the left, and they provide this to other IT teams. If that's the case, then that's fantastic, because a lot of these decisions are made for you and the framework and the guardrails are already there. If they're not there, here are some questions you should ask if you're going to build your own. What are we configuring? Is it ACI? Is it a box-by-box fabric? Are there servers involved, firewalls, load balancers? What is the network infrastructure that needs to be configured? What type of IEC tool are we going to choose? I'll list a couple of there. Do we have access to server hardware to build this ourselves? Can we support it? Does our network operations team have the skill set to manage this? That can be a tough question to ask, but I encourage you to ask it, because if you don't have the skill set, what we don't want to do here is embark on this automation journey and cause downtime or make changes that we're unclear of or unsure of because we don't necessarily have the correct skill set. So let's enter right now Hashicorp Terraform. So I imagine that everyone in the audience here knows a little bit about Hashicorp Terraform, especially if you're in public cloud, especially if you have a cloud operations group. Hashicorp Terraform is the dominant infrastructure as code tool for public cloud provisioning. Now, what some of you may not know, and what I've learned probably in the last 90 days, is that Terraform is also quite robust for private cloud infrastructure development and deployment. And by private cloud, I mean on-premise. And in the case of this presentation, I mean there are robust, verified Terraform cloud providers, not only for ACI, but also for the Nexus Dashboard Orchestrator, which used to be called the multi-site orchestrator, and you see here in the slide. So this is an example of how we can take a hybrid cloud deployment model using a unified policy model provided by ACI and its sidecar, Cloud ACI, and write out our infrastructure as code using Hashicorp configuration language. This is reusable, this is shareable, this is secure. And this is how guy number 2 would probably end up deploying infrastructure as code and building an automation platform from scratch. So now I want to bring this all together. So this is a picture that I've shared in 2 contexts. The first context was in the data center interconnect context. How can we use Nexus Dashboard Orchestrator along with ACI to automate the DCI? The second is in the security context. And that would be this EPG you see shaded at the bottom. How do I stretch security rules from one platform between an on-premise site and a cloud site and abstract the policy model so that it looks like a single policy model? But the picture is not yet complete until we add the operator. And in this case here, we have a network operator that is writing Terraform plans used to send configuration to the API of the Nexus Dashboard Orchestrator, which in turn is configuring the APIC and Cloud APIC in the unified connectivity and policy model. So this is sort of provides a complete story here. How do I stretch into the hybrid cloud, into the public cloud using ACI? And then how can I configure that in a unified fashion using Terraform? Finally, if I were to go back a couple of slides to the picture I had where the team decided to automate, but they ended up doing ongoing development and losing the time that they needed to do the original task. So another thing to be aware of, and this is not just with Terraform, this is with any automation effort or automation journey. They typically start with one curious engineer starting to run automation jobs on their laptop. That catches on. 2, 3, 4 engineers start to do it. And the next thing you know, you have individual engineers choosing the tasks that should be automated and writing automation routines based on how they think it should be done. And that's perfectly fine. Perfectly fine until you reach production, until you reach a workload that is critical. And that is where I'd like to introduce this Terraform Cloud for Business product. I like to think of this product as an out-of-the-box automation platform for NetOps. In other words, if you do not have the skill set or the time to build your own automation platform, and having done so in a previous life, I can tell you that that is not simple. This Terraform Cloud for Business product is a SaaS product that sits in the cloud that allows network operators to immediately start to ramp up using Hashicorp configuration language and Terraform Cloud for Business. I can also tell you, compared to other tools, the learning curve for Hashicorp Terraform is quite low. So this is actually an integration that I am working on with some of my colleagues at Hashicorp to bring Terraform Cloud for Business to Cisco ACI via the Nexus dashboard, and to build really this out-of-the-box automation platform to configure Cisco network components from the Nexus dashboard using Terraform Cloud for Business. Finally, I want to sum up by giving some guidance as to where to go next and what else is out there. Cisco and Hashi have a robust development community that you can find at DevNet. If you look at the link up here, developer.cisco.com, and go to automation-terraform, you will see robust examples of exactly what we talked about today, but at a much more technical level. DevNet is a great place to meet other like-minded developers, to look at different use cases, and to continue your journey in the automation. So thanks very much for listening. It's been a pleasure to present to everybody today, and thank you very much.
Good afternoon, good morning, good evening, folks, from wherever you are around the world. At this point, we wanted to open up to questions from the audience. I do see a couple have been inputted into the question box there on the right. So if you have anything you'd like to ask, please put it there. We've got a couple here that I'm going to start off with. Let's get started. Does it matter what type of Terraform I use? In your presentation, you talk about Terraform open source and Terraform Cloud for Business. What are the pros and cons of one versus the other? So I like to think of Terraform OSS and open source as a great way to learn the language and to make sure you are confident in understanding how your automation targets are working with your provider. As I talked about in the presentation, as you begin to grow and scale that model, where you may reach a situation where you have multiple discrete groups or even discrete single engineers that are making decisions about what to automate and how, you can find that very quickly that may not scale the way you want it to. And so when I think about and was introduced to Terraform Cloud for Business, my immediate thought was, this is an outstanding way to collaborate and to share and to provide collaborative tools to a team where doubled work may be minimized. Another thing that you get with a Terraform Cloud for Business product that you don't get with a Terraform open source is you get the software as a service management, you get the security, and you get the compliance that you would need that can be very difficult in building. Excuse me. In building your own automation platform. So I like to think of the Terraform Cloud for Business product as a turnkey way to go from really no automation and no automation platform to up and running very quickly. Another thing about Hashicorp configuration language and Terraform in general is that the learning curve, what we need to remember about network operators is they are very technical, and having configured networking devices in their careers, the jump from doing that to learning Hashicorp configuration language is not a big jump at all. It's a jump that most can make. The big challenge in getting production grade automation is building the platform, especially for a network operator. And I think a network operations team is a little different in that regard as compared maybe to another IT team. All right. Okay. Got this one. How hard is it to learn Terraform HCL compared to other automation platforms? Kind of touched on that one. My opinion, it's quite easy to learn, especially if you come from a background of NetOps and configuring Cisco devices and other network infrastructure. Jim, in your slides, I see that part of the cloud ACI solution involves the Cisco CSR router. What is the purpose of the CSR router, and what is the relationship between Cloud APIC and the CSR router? That's a good question that I didn't really call out there in the slides. The CSR router is there to terminate the data center interconnect from your on-premises environment. And the configuration of that CSR is automated from a prescriptive DCI strategy using NDO. The CSR also serves as a VTEP to extend the routing domain from the on-premises data center into the cloud so that you can have a single routing domain that stretches between sites without having to configure much manually. And again, I sort of talked about this during the presentation. In a previous life, I stretched DCIs from on-premise into Azure. And I can tell you, it can be quite painful because you have to think about things like, where do you terminate these tunnels? How many security enforcement points are you putting in the path? Because if you put 3 or 4 security enforcement points in that path, then you're tripling the amount of work you need to do from a policy perspective or from a security perspective. So the CSR basically serves as a landing spot for the VTEP and the VXLAN tunnel to extend the on-premises network. Let's see, Jim, can we stretch layer 2 from on-prem into the cloud? You only mentioned L3 routing domain stretch. That's correct. As of now, and probably for the foreseeable future, the L3 stretch or the VRF stretch is where we are. And mostly that's because cloud providers don't have any notion of a broadcast domain or even a VLAN. And so when you talk about how do I stretch a layer 2 broadcast domain into the cloud, it's extremely challenging. And so as of this moment, we are limited to this L3 stretch, and that's to AWS, Azure, or the GCP platform. Okay. Yes. So apologies for the technical difficulties. I see someone says here, listening to traffic and other noises, not the speaker. Apologies for that. We did experience some technical difficulties there during the presentation. And please share the slides, and we will do that. I will defer to the moderators of this content as to how those slides will be shared. So what I want to do now, I want to pause here for about 15 seconds and see if there are any other questions that someone would like to pose in the question box there. And if there are not, then I wanted to say thank you for being here. I know everybody's very busy. I enjoyed this opportunity to present to you, and thank you so much for listening. With that, I think I will turn it back over to Toby and Rachel.